All right, today we're going to talk about tangents, what they are and how they relate to circles. So vocab to start off with. A tangent is a line that touches a circle in exactly one point. So a line that touches a circle in exactly one point. So an example here, if we draw a circle, the tangent would come from the center. A tangent is going to come along and then touch in just one point. So it'd be something like this. It'd be a tangent. And you can have more than one tangent to a circle, like anything that touches the circle in one spot is a tangent. I'm going to call this C for the center. And let's call this P. All right, so the tangent radius theorem says if a tangent and the connecting radius are perpendicular. So if I connected the center out like this, so this is your radius, this has to be a 90-degree right there. So let's call this A and B. So AB has to be perpendicular to CP. So how can we use that? So here we want to figure out with this one, what is this x value? Well, we have a radius right here. We have a tangent right here. So that means this has to be a 90-degree angle right there. And then a triangle adds up to 180. So we know we have 180. We can subtract 38 and subtract 90 to get x. And you should end up getting 52 for x. So another example here, we have two tangents and two radiuses. So we have some nice 90-degree angles. And then we want to figure out what x is. So here there's a couple different options. First, if you sketch this in right here, we have two triangles if we cut it in half. So we have one triangle and two triangle. So you can double 180 to get what your total should be. So 180 times 2 is 360. So then you can do 360 minus 117 minus 90 minus 90 and get an answer of 63 for x. Or if I do it in a different color, you could do 180 and then subtract half of 117 and then subtract 90 and you'll get an answer and then multiply by 2 to give you your x. So either one is fine. It doesn't matter to me which you do. Okay, another definition. So the tangent radius converse theorem. This is basically taking the tangent radius theorem and saying it backwards. So if you have a line perpendicular to a radius, then that line has to be a tangent. So if this line right here is perpendicular, that means it's a tangent. So if a line is perpendicular to a radius, then the line is tangent to the circle. And that's what this picture here is showing. So you have a radius right here. You have a 90-degree, which makes this a tangent. So how can we use that? So the question here is ML a tangent? So is this line a tangent? So to figure that out, we want to figure out, is this 90? is this angle 90? And to do that, we have three sides of a triangle. So you can check to see if this satisfies the Pythagorean theorem, and that will tell you if it's a 90 degree or not. So do your a squared plus b squared equals c squared. So the hypotenuse would be this. This would be a, this would be b. So 7 squared plus 24 squared equals 25 squared. Put this into a calculator. You'll get 625 on this side, 625 on this side. It worked. So yes, this is tangent. If you got two different numbers like 625 and 530, then it would not be a tangent because you didn't get a right triangle. So this one, similar kind of idea. We want to set up our a squared plus b squared equals c squared, but it's going to be a little different because we have these x's. So this will be the a, this will be the b, and then this whole length is c. So c is going to be x plus 8. So we write it out, you get x squared plus 12 squared equals x plus 8 squared. And then here we have to go back to intermediate algebra when we FOILed stuff out. So you want to rewrite this as x plus 8 times x plus 8. And then you have to FOIL. So I want to take x times x and then x times 8 to get x squared plus 8x. And then you're going to take 8 times x and 8 times 8 to get 8x plus 64. And then the other side just stays the same. So we have x squared plus 12 squared on this side. So you get x squared plus 144 equals x squared plus 16x plus 64. So then these x squares are going to cancel because they're both on the same side. And then we have 144 equals 16x plus 64. Subtract the 64 and you get 80 equals 16x. Divide by 16 and x equals 5. So a little bit more complicated solving, but you set it up the same way. The last definition here is the congruent tangents theorem. So if you have two tangents like AB and BC and they touch, they connect, then these have to be congruent or the same length. So if two tangents intersect, then they are congruent. So how can we use this? So here's two tangents connecting. This one was 10, so this one also has to be 10. This one has to be 8, and this one has to be 15. So if we want to find the perimeter, we just need to add those all together. So you want to do 10 plus 10 plus 15 plus 15 plus 8 plus 8 to get your perimeter, which will end up being 66 centimeters. Last one here. So we have another shape. We want to figure out what is QY. So this is our X. We don't know what that is. I'm going to call it Z. So this one has to be 15, this one has to be 17, and this could be another Z since they're the same. So adding these up, we know they have to equal 88. So 88 equals 15 plus 15 plus 17 plus 17 plus Z, which will then give you 64 plus 2x equaling 88. Subtract 64, and you get 24 equals 2x divided by 2, and x equals 12. So that's it. This is your optional homework if you want some bookwork. Otherwise, go on Math Excel and do the 12.1.